This tutorial reviews what can be worked out given an atom's atomic number and mass number, also the electron configurations of atoms, reviewing what group number and period number are in terms of electron configurations of atoms, understand how atoms form ions, and to know the charges of common ions and be able to write formulae for compounds involving these. The first 8 minutes discuss what you can work out from atomic number and mass number, or from electron configurations. From 8 to 10 minutes, it covers the formation of ions. From 10 minutes onwards, it covers the formula of ions and writing chemical formulae. First, let's think about what we can work out when we're given the following. This is showing fluorine with the atomic number and the mass number. Pause the video, think about everything you can work out, and then push play. There are a lot of things we can work out. So, for example, we could find out the mass number, the atomic number, and if we know the atomic number, we know the number of protons, and as it's an atom, the number of protons will be equal to the number of electrons. The mass number is neutrons plus protons. So if we know the number of protons, the difference between the mass number and the number of protons is equal to the number of neutrons. If we know the number of electrons, we could obviously work out the electron configuration. Once we've got the electron configuration, we can work out how many electrons are in the outer shell and how many shells of electrons we've got. And if we know the number of electrons in the outer shell, we can work out what group it's in. And if we know the number of electron shells, we can work out what period it is in. So the bigger number is the mass number, which is 19. The atomic number is the smaller number associated with each element, which is 9 in this particular case. If it's got an atomic number of 9, this means it's got 9 protons. Atoms are neutral, so this means they have the same amount of positive protons as they have of negative electrons, so this atom will have 9 electrons. The number of neutrons is the difference between the bigger number, which is neutrons plus protons, compared to the atomic number, which is the number of protons. So the difference between these two numbers is 10, so it has 10 neutrons. The electron configuration is how the electrons are arranged in the shells. First shell can contain a maximum of 2 electrons. So if we have 9 electrons in total, this means we'll have 2 in the first shell and 7 in the second shell, as shown in this little diagram here. The group number is the same as the number of electrons in the outer shell. So if we counted the number of electrons in the outer shell, we would find it is in group 7. The second thing is what period is it in the periodic table. And if we look at the number of shells, we've got the first shell with 2 electrons in, second shell with 7 electrons in, so it has 2 different shells, so it will be in period 2 of the periodic table. So here we have a diagram of an atom. What can we work out from a diagram? In the center is the nucleus. So the things which are found in the nucleus are protons and also neutrons, the things which have the significant mass which contribute to the mass of an atom. So you can obviously work out the mass number for this atom. The mass number will be equal to everything found in the middle, so that will be 9. The next thing we could work out is the atomic number. The atomic number is equivalent to how many protons are there. Protons are the positive particles. In the center there are 4, so we could say there are 4 protons. The next thing we could obviously work out is the number of electrons. If we look at the diagram, 1, 2, 3, 4. So it has 4 electrons. As it has the same number of protons and electrons, it isn't an ion but is an atom. The number of neutrons is going to be the things with no charge, which are found in the center, and the diagram has 5 of those, so 5 neutrons. The electron configuration is how are the electrons arranged in the atom. 2 in the first shell, 2 in the second shell. In the outer shell, we could look at how many electrons there are, and it's 2, so this must be found in group 2 of the periodic table. Next thing is how many shells of electrons there are. There's the first shell there, the second shell there, so it has 2 shells of electrons. That's equivalent to the period number. What can be worked out from this dot and cross diagram? The circles represent electrons, so we can work out the number of electrons. If we count them, we'll find there are 20. If we're assuming it's an atom, and we are because there's no charge shown in the top right corner, it should have the same number of protons, so it should have 20 protons. The atomic number and the proton number are the same thing, so it has an atomic number of 20. We could also write the arrangement of electrons in the different shells. 2, 8, 8, 2. We could say how many electrons are present in the outer shell. These 2 here. So 2, or from the text here, which is equivalent to the group number. The next thing we could do is work out how many electron shells there are. 1, 2, 3, 4. So it has 4 shells of electrons, which is equal to the period number. If we look at the periodic table, we can find what element is found in group 2, period 4, and we would find it's calcium. The other thing we could obviously do is use the atomic number to find it on the periodic table, and we could write on calcium below the atomic number. What information can be shown from this dot and cross diagram? Well, in the top right we can see the charge on the ion. So that would be one thing we could mention. So the charge is 2 plus. We could calculate the number of electrons by counting the electrons in each of the shells. 2 plus 8 plus 8, giving you 18 electrons. We could also calculate or work out the ion's electron configuration. So 2 in the first shell, 8 in the second shell, and another 8 in the third shell. We can now think about what the atom's configuration is for which it formed this ion. So thinking about what formed this, if it's got a charge of 2 plus, it must have lost 2 electrons. So we need to add 2 electrons to this diagram to show the original atom's electron configuration. So what's the atom's electron configuration? 2, 8, 8, 2. So now we've got the number of electrons in an atom, we can work out the number of protons in an atom. 2 plus 8 is 10, plus another 8, 18, plus another 2, 20. The atomic number is equal to the number of protons. And if we look at this diagram, we can see how many electrons in the outer shell, 2, which is equivalent or equal to the group number, so it's in group 2. We can now think about how many electron shells there are in the atom, 1, 2, 3, 4. So it's got 4 shells of electrons in the atom, that is, so it's going to be from period 4. Ions. You need to understand how ions are formed by either the gain or loss of electrons. Pause for the video and see if you can answer how metals and non-metals form the ions, which they do form. Metals form positive ions by the loss of electrons. Non-metals form negative ions by the gain of electrons. We're going to look at this in a little bit more detail. How does a fluorine atom form an ion? So here's a fluorine atom. It's got 7 electrons in the outer shell. And what it will do when it forms an ion is gain or lose electrons to obtain the same electron arrangement as the nearest noble gas. So it could either lose 7 or gain 1. So what it's going to do is gain 1 electron to become a fluoride ion. You can see it's going to be probably easier to just, or less, more energetically favourable to gain 1 electron rather than lose 7. So here we have a picture of a fluoride ion. As it's got now 1 more electron than before, it's got a negative charge because it still has 9 positive protons in the middle, but now it has 10 electrons. So it's got 1 more electron than it has of protons. How does a lithium atom form an ion? So for metals, they are going to lose electrons, so it will lose this electron to form a positive ion. So a lithium ion will have a charge of +1 because it has lost 1 electron. Difference between atoms and ions. For example, for a lithium atom, it has the same amount of positive protons as negative electrons, so it is neutral and it has no overall charge. Whereas in a lithium ion, it has lost an electron, so now it's only got 2 electrons compared to 3 positive protons, so overall it will have a charge of +1. Give an example of a group 2 metal and state the charge on its ion. Give an example of a group 7 non-metal and state the charge on its ion. Give examples of ions whose charges and or formulae must be learned. So pause the video, see if you can answer that, and we'll go through that in a second. So maybe one way you could do this is draw a table and then work out what is in the table. So group 1 metals, for example, will form +1 ions. An example of this might be Li+, Na+, K+. Group 2 metals form 2+ ions. So for example, we might have calcium 2+ or magnesium 2+. Group 3 metals form 3+ ions. So for example, aluminium 3+. This is because everything in group 1 has 1 electron in its outer shell, and so to obtain a full outer shell it will lose 1 electron. Group 2, it has 2 electrons in its outer shell, so to obtain a full outer shell it will lose 2 electrons. So if we start with group 7 non-metals, they've got 7 electrons in their outer shell, and to obtain a full outer shell they will need to gain 1 electron, so it will form -1 ions. Group 7 is the halogens, so we could have fluoride, chloride, bromide or iodide. Group 6, it has 6 electrons in the outer shell, and to form a full outer shell it will need to gain 2 electrons, so for example we might have O2-. Group 5, 5 electrons in the outer shell, and to obtain a full outer shell it will need to gain 3 electrons to form a 3- ion, so for example N3-. So let's see if we could draw a dot and cross diagram for the following 5 ions. So a lithium ion. So the strategy is to work out which group of the periodic table it's in. Lithium is in group 1, so it knows forms +1 ions. The other thing for lithium though, it's a one exception which has a slightly different diagram to the others. A lithium atom, if you found it on the periodic table, would have a number 3 for its atomic number. That means its electron configuration is 2, 1. So when it forms an ion, it will lose its outer shell electron and it will become Li+. So the diagram for it will look like this. It's lost its outer shell electron. We can see the charge in the top right corner, and we can see the inner shell of 2 electrons. Magnesium, we know it's got a charge of 2+, and obviously maybe we could also work out the same details for this one as well. So using magnesium, if we look at it on the periodic table, we find it's got a number 12 for its atomic number, so that means its electron configuration is 2, 8, 2. So when it forms an ion, it will lose its outer shell electrons and become an Mg2+ ion. Aluminium is in group 3 of the periodic table. So that means it's got 3 electrons in its outer shell. But as we're looking at the full configuration, we would need to know its atomic number, which is 13. So its atom's electron configuration is 2, 8, 3. So when it forms an ion, it will lose the 3 electrons in the outer shell and become an aluminium 3+ ion. So oxygen is in group 6 of the periodic table, so we would expect to have 6 of its own electrons in its outer shell, a charge of 2-, and 2 electrons of a different sort because it's obviously gained 2 electrons. So if we look here, we've got 6 of its own electrons in its outer shell and 2 electrons which is gained, and a charge of 2-. Again, if we were going to work it out from scratch, oxygen has an atomic number of 8, so 8 electrons, so the electron arrangement would be 2, 6, which we can see in the dot and cross diagram for oxygen. We can see 2 in the first shell, 6 in the other shell, the outer shell. It's obviously got to gain a full outer shell, so it gains 2 electrons, which are shown here. The charge will be 2-. The last one we've got is a fluoride ion. It's in group 7, so it should have 7 of its own electrons in its outer shell. It's gained a charge of -1, so it should have an electron which will have gained from somewhere else. So let's look at the diagram and see what we've got. We can see it's got 7 electrons of its own sort in the outer shell, which are these red circles, and a gained electron, which is a red cross. So we can also again work it out from scratch. Fluorine has 9 protons, so it will have an electron arrangement of 2, 7. When it forms an ion, it will gain 1 electron to obtain a full outer shell, so it will become 2, 8. And it now has gained an extra electron compared to an atom, so it will have a charge of -1. So there are certain ions which we need to just learn. Silver, Ag+, ammonium, NH4+, meaning 1 nitrogen, 4 hydrogens with a charge of +1, the hydrogen ion, H+, zinc 2+, lead 2+, copper 2+, iron 2+, and iron 3+. These here you can usually work out because it will either tell you it's Fe2+ or Fe3+, in terms of either the name, calling it iron 2 something or iron 3 something, or from the formula. And we also have this other ions we need to learn. Sulfate ion, SO4 2-, meaning 1 sulfur, 4 oxygens with a charge of 2-. Carbonate ion, 1 carbon, 3 oxygens with a charge of 2-. Nitrate ion, 1 nitrogen and 3 oxygens with a charge of -1. And the hydroxide ion, a charge of -1. So this next bit is a recap of how you write formulae for compounds. It tells us that magnesium is in group 2 of the periodic table and chlorine is in group 7. So the first thing we could think about is, what do we need to do? We need to think about what the 2 ions present are. Everything in group 2 will form 2+ ions, and everything in group 7 will form -1 ions. The next thing we need to do is say, what is the size or magnitude, what is the numerical component for each of the ions? So the number associated with magnesium 2+ ion is 2. The number associated with chloride ion is 1. The next thing we can do is do swap and drop. So we write the 2 elements down, and we're going to swap the 2 numbers around. So the 2 goes after the chlorine, and we happen to not write 1s down, so we ignore 1s. So this gives us a formula, MgCl2. The other way of doing it is thinking about it in terms of charge. We've got a magnesium 2+ ion and a Cl- ion. So to balance the charge, if we've got 2 positives, we must have 2 negatives. So for every magnesium 2+ ion, we must have 2 Cl- ions. Next one we've got is aluminium oxide. Aluminium is in group 3 of the periodic table, and oxygen is in group 6 of the periodic table. We could write the charges of the ions down. Aluminium is in group 3, so it will form an aluminium 3+ ion. Oxygen is in group 6, so it will gain 2 electrons to form an O2- ion. We again work out the size of the ion's charge, so 3 and 2. We now write down the elements below to do swap and drop, and we swap the 3 and the 2's positions. There aren't any 1s, so it doesn't matter, so it becomes Al2O3. The alternative way of doing this is in terms of balancing charge. We write the 2 ions and their charge down. At the moment we have more positive charge, so we might add some negative charge. We've got 3+ versus 4-, so we now add some more positive charge. We've got 6 positives, and it still isn't balanced out by the oxide ion's charge, so we need to add an extra oxide ion, which now balances out, so we've got 6 positive charges balanced by 6 negative charges. What is the formula for iron 3 hydroxide is the next question. Roman numerals indicate the magnitude of the charge on the ion. So iron is a metal, so the ion's charge will be 3+. So let's lay this out. We've got ions, iron with a charge of 3+, hydroxide with a charge of -1. Let's write down the size of the ion's charge for both. So iron has a charge of 3, in terms of a number part, and hydroxide has a 1. If we do swap and drop, we can swap the 3 and the 1 over, remembering to ignore 1s. I put some sort of pretend brackets around the hydroxide ion. This is just reminding me that with ions consisting of more than 2 elements, so for example OH consists of an oxygen and a hydrogen, if we have more than one of these we will need brackets. So if we do swap and drop, we've got a 3 outside of this OH, so that means we need to have brackets. So the formula of iron 3 hydroxide is Fe open brackets OH close back brackets 3. Balancing of charge, if we write the 2 ions down, we can see we still at the moment have more positive charge, so to balance it we need to add another 2 hydroxide ions, which will mean we have the same amount of positive and negative charge. What is the formula of ammonium carbonate? Same process as before, write down the ions which are present, so the NH4 plus ion and the CO3 2 minus ion. When we're trying to find out the size of the ion's charge, we need to be careful to make sure we're using the 1 for ammonia and the 2 for the carbonate ion. We obviously now do swap and drop, write the 2 ions down and swap the 2 and the 1. We remember not to write down 1s obviously. And you can see here the potential chance for having brackets could go here and here. We can see we will need brackets for the ammonium ion because we have got 2 of these ions which consist of more than 2 elements. Whereas the carbonate ion, there's only 1 of those, so it doesn't need brackets. Again, just balancing charge, we can see we have 2 ammonium ions for every carbonate ion. A common way that the examiners now test your understanding of formulas, sometimes they accept you may not be as certain of the formula for ions, but what they do really care about is the application. So it might give you some examples of how some ions combine. So for example, sodium ion combines with chloride ion to make sodium chloride. And it might have 3 question marks in the table and ask you to complete the table. So let's write these out as a sort of maybe simpler form here. So it might ask you, complete, what's the formula of ammonium sulfate? And you can see here, you could combine that ion and that ion, iron 3 hydroxide combining this ion and that ion, zinc hydroxide combining that ion and that ion. So you can always pause the video, see what you come up with as your 3 formula, and then we will go through it. What is the formula for ammonium sulfate? Let's write down the ions. Let's write down the size of the charge as ions. And let's do swap and drop. So write the formulae down, swap the 1 and the 2 over. Don't forget that we may need brackets. We might even need brackets on the sulfate, but we don't as there's only 1 of those. So the formula is NH4 2SO4. Balancing charge, we can see there's the same amount of positive charge as there is negative charge. Let's do the next one. What's the formula for zinc hydroxide? I learned that the charge of a zinc ion was 2+ because I think the Z looks a little bit like a 2. So again, write down the ions. Work out the size of the ions' charges. Do swap and drop. Don't forget that the hydroxide ion may need brackets around it if we've got more than 1, and it looks like we're going to need more than 1 of those. So it's got brackets. So zinc hydroxide has the following formula. In terms of balancing charge, for every zinc 2+ ion, there are going to be 2 hydroxide ions. What's the formula for iron 3 oxide? Remember, Roman numerals indicate the magnitude of the charge on the ion. And as iron is a metal, it will be a positive ion. So we write down the ions, work out the size of the ion's charges, so 3 and 2. Write the elements symbols below and do swap and drop, which gives us Fe2O3 as its formula. Balancing charge, we can see that for every 2 iron 3+ ions, we'll need 3 oxide ions.